This lesson is about multiplying exponents. If we look at example number 1, it says 3 to the 5th times 3 to the 4th. If we actually wrote out 3 to the 5th, it would look like this, times 3 to the 4th, which would look like this. If you look, we could actually rewrite this as 3 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 3 to the 9th. M to the 3rd, m times times m squared, m to the 5th. Over here on the last example, we have x to the 8th times y to the 5th times x squared times y. So x, we have 8 of them. 3, 4, 5, 6, 7, 8. 5 y's. We're going to have to keep going here. Times x times y. So if I look at all the x's, there's actually x to the 10th power and y to the 7th power. 6th power. There's only 6 of them. Can't count this morning. So here's the deal. You might have picked up on this already. 3 to the 5th, 3 to the 4th gave us 3 to the 9th. M to the 3rd, m squared gave us m to the 5th. This example, x to the 10th, y to the 6th. Notice the exponents here. When you're multiplying exponents and they have the same base, keep in mind when you're talking about an exponent, like 5 squared, this is your base and this is your exponent. When they have the same base number, all you have to do is add the exponents together. So for example, in number 4, the base is both 3, so all I have to do is add my exponents. Negative 2 plus 6 is going to give me 4. 3 to the 4th is my answer, and that we're going to actually require you to do because it's 81. Example number 5. My base is both m, so all I have to do is add my exponents. 2 plus a negative 5 is going to give me negative 3. However, with our rules, we cannot leave that because it's a negative exponent. So you need to rewrite this as 1 over m to the 3rd. Example number 6 here, we have a lot of things going on. Bases have to be the same. It's kind of like when you were combining like terms. It's a similar idea. X to the negative 7th, x to the 5th is going to be x to the negative 2 because negative 7 plus 5. Look at your y's. You have an 8 and you have a negative 4. That's going to give you 4. Issue here, you have a negative exponent, so you need to rewrite this. X squared goes on the bottom, y to the 4th on the top. Final answer. Example number 7, x times x squared times x to the negative 4th. You need to realize that a plain old x is actually x to the 1st. So these are all base x. So 1 plus 2 is 3, plus a negative 4 is negative 1. Negative exponents not allowed. 1 over x to the 1st, which we really just write as 1 over x. In here, we have negative 7 times x to the negative 3rd times x to the 8th. The negative 7 is the only one that has a base of negative 7, so we're going to keep it. The x's have the same base, so negative 3 plus 8 is going to be x to the 5th. This is not a negative exponent, it's a negative number, so it does not need to move. In this one, your bases are negative h. So you have negative h to the 3rd and negative h to the 4th. A negative times a negative will actually result in a positive. H to the 3rd, h to the 4th, so you have h to the 7th, and that's your final answer. Why are these in parentheses though? It's so that you can tell that it doesn't mean minus h to the 4th. The parentheses tell you to be multiplying. However, your exponent only applies to your h. The negative is sitting out front. That's a confusing one. In example 10. If we look at this one, we can actually multiply the plain numbers. Those are called constants. 2 times negative 3 is a negative 6. A's, add your exponents, you're going to get a to the negative 2. B's, add your exponents, you're going to get b to the 3rd. Issue because you have a negative exponent. So your final answer is negative 6 over a squared. B to the 3rd stays on the top. Example number 11. 1/3 times 2 times 6. Those are all your constants. I'm going to actually use the commutative property. 1/3 of 6 is going to be 2, and 2 times 2 is going to be 4. A, there's only one of them, so a to the third. B, this is b to the first, so 1 plus 3 is 4. Final answer. Example number 12. I have negative 5xy times 4x squared times y to the negative 4th power. Constants, negative 5 times 4 is negative 20. The x's, this is x to the first and x squared, so I'm going to get x to the third. And then I have y and y to the negative 4th. Add that up, I get y to the negative 3rd. Not done, no negative exponents allowed. Negative 20 stays on top. X to the 3rd, y to the 3rd needs to move down. Over here, lots of stuff going on. Constants, negative 20. X, negative 3 plus 1 is going to be negative 2. Y is 1 and negative 5, so that's negative 4th. And z is negative 2 and 6, so that's to the 4th as well. But this one was a negative, that one's a negative. We got to do a little cleaning up. Negative 20 is just a number. It's going to stay up on the top. Sorry about that. X to the negative 2, that needs to move down, become x squared. Y moves down, becomes y to the 4th. And z to the 4th stays up on the top. 2 more examples for you here. In example number 14, constants, 4, a to the 3rd, b squared, c to the 0. We talked about 0 power, it just means 1. So this is really 4, a to the 3rd, b squared. Last example here, negative 3 times 3 is 9, a to the negative 1st, b to the 7th, n to the negative 4th. Your bases should be in alphabetical order. That's why I put the n before I did the b. Clean this up though because you have negative exponents. 9, a, b to the 7th stays on top, n to the 4th goes to the bottom.